ఇస్మాయిల్ గారు ఓకేనా? ఇస్మాయిల్ గారు ఓకేనా? ఇస్మాయిల్ గారు ఇస్మాయిల్ గారు హలో ఓకేనండి. ఓకే అండి. గుడ్ మార్నింగ్, సత్ శ్రీ అకాల్. The land of five rivers known as Punjab is agriculturally and culturally rich with roots in history going back to thousands of years. The border state, actually this is the border state for with Pakistan, is closely associated with the many టూరిస్ట్ డెస్టినేషన్స్. అలాంటి టూరిస్ట్ డెస్టినేషన్స్ లో ఇవాళ ఒకటి రెండు ప్రాంతాల గురించి మనం డిస్కస్ చేసుకుందాం. ద ఫస్ట్ వన్ ఈజ్ నోన్ యాజ్ హర్మిందర్ సాహెబ్ అండ్ దట్ ఈస్ ఆల్సో నోన్ యాజ్ ద గోల్డెన్ టెంపుల్, పిలిగ్రిమ్ స్పాట్ ఫర్ ద సిక్ కమ్యూనిటీ. ఇది వినంగానే మనందరికీ కూడా ఆ పిక్చర్ ఏదైతే ఉందో గోల్డెన్ టెంపుల్ మన కళ్ళ ముందు కదలాడుతుంది. హర్మిందర్ సాహెబ్ ఆర్ ద గోల్డెన్ టెంపుల్ ఈజ్ వన్ ఆఫ్ ద మోస్ట్ ఇంపార్టెంట్ ప్లేసెస్ to visit in the state of Punjab, located in Amritsar. Construction of the Golden Temple commenced in 1585 AD. అంటే దాదాపు 4 నిర్మించబడింది. By the fourth Sikh Guru, Guru Ramdas Ji, and completed in 1604. దాదాపు 19 నుంచి 20 సంవత్సరాలు. And there is a లేక్ దట్ సరౌండ్స్ ద టెంపుల్. మామూలుగా హిందూ టెంపుల్స్ లాగానే చాలా వరకు హిందూ టెంపుల్స్ కోనేరు పక్కన ఉంటాయి. కానీ అమృత్సర్ లో గోల్డెన్ టెంపుల్ యొక్క విశిష్టత ఏమిటంటే ఇది కోనేరు మధ్యలోనే ఉంటుంది. The lake, also known as Sarovar, is considered to have holy water that has medicinal properties. The opening and closing time of the temple is 6 a.m. to 2 a.m. ఇది గోల్డెన్ టెంపుల్ గురించి. అట్లాగే మనం హిస్టరీకి వెళ్ళినట్లయితే ఇక్కడ దీని దగ్గరలోనే ఉన్న ఒక ముఖ్యమైన ప్రాంతాన్ని మనం గుర్తు చేసుకోవచ్చు. దట్ ఈస్ జలియన్ వాలాబాగ్. మనకి 10th క్లాస్ వరకు కూడా ఈ జలియన్ వాలాబాగ్ మాస్కేర్ గురించి చాలా చదువుకుని ఉంటాము. Located at a very close proximity to the Golden Temple, Jallianwala Bagh is basically a public garden in which there is a memorial that reveals the massacre carried out by the British forces that killed thousands of peaceful celebrators. మన స్వతంత్ర ఉద్యమ కాలంలో ఇక్కడ వాళ్ళ యొక్క అశాంతిని తెలియచేయడం కోసం ఇక్కడ కాంగ్రిగేట్ అయినటువంటి మన స్వాతంత్ర సమరయోధులందరూ కూడా ఇక్కడ ఒక మీటింగ్ పెట్టుకుని కలవడానికి వస్తే, మాట్లాడడానికి కూడా వస్తే ఎంత శాంతియుతంగా చేపట్టినప్పటికీ కూడా బ్రిటిష్ వారి దుశ్చర్యలకి ఇక్కడ లోనవడం జరిగింది. సో ఈ రోజు కూడా అది మనకి ఒక బాధాకరమైన సంఘటన కింద భారతీయుల మనసుల్లో చోటు చేసుకుని ఉండిపోయింది. సో జలియన్ వాలాబాగ్ పేరు వినంగానే మనకు అదే సంఘటన మరలా గుర్తొస్తూ ఉంటుంది. When we visit Jallianwala Bagh, we can still see the well in which several people jumped in to save themselves from the bullets of the British forces. The hours to visit Jallianwala Bagh are from 6:30 to 7:30 p.m. చాలా మంది అక్కడ ఉన్నటువంటి ఎత్తైన గోడ ఎక్కి తప్పించుకొని పారిపోవడానికి చూశారు దూకి. మిగతా వారిలో కొంతమంది తమ ప్రాణాలని కాపాడుకోవడానికి అక్కడ ఉన్నటువంటి పెద్ద బావిలో దూకడానికి ప్రయత్నం చేశారు. కొంతమంది ఆ విధంగా ప్రాణాలు కూడా కాపాడుకున్న వారు ఉన్నారు. అయితే అక్కడికి వెళ్ళంగానే అది ఉద్యానవనము అని ఒక మనసుకి ఆనందం కలిగించే బదులు ఆనాటి ఆ బాధాకరమైన సంఘటన గుర్తుకొచ్చి మన అందరి మనసుల్ని కూడా కళ్ళల్లో నీరు తెప్పించే విధంగా గుర్తు చేస్తూ ఉంటుంది. సో ఇటువంటి చారిత్రకమైన ప్రదేశాలు అలాగే పౌరాణికమైన ప్రదేశాలు మంచివి పంజాబ్లో ఇంకా ఎన్నో ఉన్నాయి. కొద్ది రోజులు వీటి గురించి మనం రోజు డిస్కస్ చేసుకుందాం. మరలా రేపు కలుసుకునే వరకు హ్యావ్ ఏ వండర్ఫుల్ అండ్ బ్రైట్ డే. థ్యాంక్ యూ. బాయ్.
Hi, this is B. Chiranjira. In this video lesson, I would like to teach Gauss law in electric charges and fields. See, actually, now let us observe the Gauss law. The total electric flux through any closed surface is equal to 1 by epsilon naught times the net charge enclosed by the surface. That means, see, if you total electric flux phi is equal to closed integral, surface integral of E bar dot ds, that is equal to q by epsilon naught. This is the statement of the Gauss law. So where q is the total charge enclosed by the surface S. This closed integral represents surface integral of the closed surface, and E electric field intensity, epsilon naught permittivity of free space. Epsilon naught is equal to 8.85 in 10 power of minus 12 coulomb square by Newton meter square. So this is all the Gauss law. Gauss law means once you know the charge enclosed the surface, once you know the amount of surface enclosed with the surface of the any body, you can find the total flux, electric flux connected with that particular surface. So you can find the electric field or electric flux with the help of Gauss law. This is most important concept in Gauss law. So now let us see what is actually Gauss law. The total electric flux through any closed surface is equal to 1 by epsilon naught times the net charge enclosed by the surface. This mathematically represented as phi is equal to closed integral E bar dot ds is equal to q by epsilon naught. Using this, we can determine the electric flux for any enclosed surface such as a sphere or long, infinite long wire or a cylinder. We can determine the electric flux due to the charge containing any surface. Now let us verify this Gauss law with some example. Take for example a sphere, hollow sphere. You consider that it is very comfort to consider a closed surface which is a hollow sphere. It is regular in its shape. Then you consider a positive point charge is at the center of the sphere, and the radius of this is, say, r. Radius of the sphere is r. And you consider any small area here, ds, and if you want to consider it in a vector form, you have to consider the area and a vector drawn normal to this area. So ds is the area and the normal drawn to this surface gives the direction. So I write here ds bar, and this is how this I consider as area, small area, and I will be considering the normal drawn to this surface. This is the area ds. So this is totally I consider as a vector ds bar. Now what happened? Due to this point charge, it gives electric field in this direction. Now, according to Gauss law, or Gauss theorem, now electric flux is equal to closed integral E bar dot ds is equal to q by epsilon naught. This is the formula for according to Gauss law. theorem, this one. Now let us observe this one. According to the definition of electric field intensity, due to this charge at a distance r is equal to, this E is equal to, at a distance r, 1 by 4 pi epsilon naught q by r. Now let us take this part, left hand side. I will take the left hand side of this E. And now this can be written as closed integral. Instead of E, you write down 1 by 4 pi epsilon naught q by, see this is r square, q by r square into ds. So right hand, this is left hand side of this equation. Now these are all constant, so I write here this is equal to 1 by, I simply write q by 1 by 4 pi epsilon naught into q by r square into closed integral ds. So closed integral ds means, see, there are such small areas enclosed around this sphere. So closed integral ds is nothing but the total small particles which contribute the total area of the surface of that sphere which is having radius r. So instead of closed integral ds, I can write down the area, surface area of the sphere is 4 pi r square. So right here 1 by 4 pi epsilon naught q by r square into, instead of this part I can write down 4 pi r square. So 4 pi cancelled, r square cancelled. What is the remaining value here? It is q by epsilon naught. So I write this is RHS. Hence, we can prove the Gauss law holds good for any closed surface which is having certain charge. The lines or the flux can be written as closed integral E bar dot ds is equal to q by q over epsilon naught. So this holds good only for the inverse square. See the square, inverse square. If you write here E is equal to, if you observe here, inverse square, E follows inverse square law. Inverse square law. So this is square. Suppose instead of r square, suppose I use cube. Inverse cube law. In square law, I just inverse cube law. What is inverse cube law? Say in dipole, in case of a dipole, what happened in case of a dipole? In case of a dipole, plus, minus, in all these cases, electric field due to the axial line is equal to 1 by 4 pi epsilon naught to p by r cube. Here the electric field intensity for a dipole on the axial line, it is following the inverse cube law. Suppose if you substitute somewhere, instead of charge, if you consider that there is a dipole like this, instead of charge, point charge, if you consider a dipole, this will not be getting q by epsilon naught, because what happened now, instead of r square you have to write down r cube, this will be r cube, and cancelled. Finally what happens, you will be getting q by epsilon naught r. So this is wrong. This will not be the Gauss law. So hence the Gauss law holds good only for the inverse square law and the charge placed on the surface or at any point, but not for dipole. It is not possible for dipole. You won't get the q by epsilon naught. So this is how we can verify the Gauss law for a simple surface, closed surface such as a sphere. Now, inverse not cup. Now we apply this Gauss law to different cases, such as a long infinite thin wire, the electric intensity due to infinite long thin wire, uniform thin wire, and uniform thin plate. Let us observe these two cases as far as our syllabus is concerned, but for spherical shell it is deleted the 30% syllabus, but anyway we can discuss for the purpose of NEET and IIT. Now let us observe the important concept. Expression for electric intensity due to an infinite long straight charged wire. So along this you may be asked to define electric flux. So before that we have to define the electric flux and then we have to answer the next part. So according to electric flux, what is the electric flux? It is the number of lines of electric lines of force passing through the area in the normal direction, normal to the area of the surface, is called flux. See, the number of electric lines of force passing perpendicular to the area is known as electric flux. So electric flux phi is equal to E dot A. It is a scalar quantity. Electric flux is a scalar quantity. You can write phi is equal to E bar dot A, EA cos theta. So suppose you consider this is a small surface and the normal drawn to this surface. For all the lines of force, the direction of the normal drawn to the surface, then in this case theta is 0. Then what happens, flux in this case, flux is equal to, from this formula, EA cos theta, cos 0 1. So the flux is maximum, in this case E. So flux is maximum if phi theta is 0. Suppose we have, there is another case like this. If surface is like this and a normal will be in this way, and if the flux is this way, then what is the angle here? Set an angle theta with respect to the electric lines of force and the normal. Then this theta is equal to set tan theta. Then what happened? Phi is equal to EA cos theta. Suppose if theta is 90, next case. Suppose if this is the surface and this is the normal drawn to the surface, then what happens? If this is the magnetic field, electric lines of force are in this direction, then what is the angle here? Theta is 90 degrees. Then what is the flux in this case? 0. This is minimum. So, the lines of force, if normal to the surface area, the flux is maximum. If normal perpendicular to the surface area, then the flux is 0. So, if you consider E bar and the aerial vector, I write here ds bar, if mutually perpendicular, then phi is 0. That is most important condition. The phi will be 0 or maximum or between maximum and minimum with this value, this equation. That depends upon theta, 30, 60, whatever it. Now let us observe what will be the electric field intensity due to a long straight wire having some charge. Now let us consider a long infinite wire, length of wire, which is having a charge, uniform linear charge density. This is the wire with uniform linear charge density. See, the wire has uniform linear charge density. So uniform charge density is denoted with lambda. Lambda is equal to total charge by its length. This implies Q is equal to L into lambda. Now for the purpose of determination of the intensity due to this wire having charge, we have to construct the Gaussian surface. This is what is called Gaussian surface of length L and radius R. This is the Gaussian surface, cylindrical shape. So this Gaussian surface, just imagine that if you just, this is the way in which we can get the Gaussian surface, the cylindrical paper, and we have a straight wire in between this, and this will be this paper is of cylindrical shape, and this wire is at the center, and at a radius of r we imagine the Gaussian surface. This is the Gaussian surface, this is the wire, and the shape of this Gaussian surface is cylindrical due to this thin wire at a radius r. So you can consider on this surface the electric field intensity can be estimated. See, so for this, say I write here A, B, C, D. So this is one top surface, this is the bottom surface, circular shape, and this is, if you cut, that will become as a rectangle. So if this cylinder, it has the top one circular surface, the bottom another circular surface, and if you remove this, you will get the shape of a rectangle. This is the shape of a rectangle. So the surface, other than, I write here this is the first surface, surface 1. I write here this is surface 1. I write here this is surface 2. And I write here this is surface 3. So, for our convenience, for the symmetry, the electric lines of force always pass through this way. This way. Electric lines of force will be passing through small area. You consider small area here. And if you consider small area on the top surface and normal to this, and the electric field in this direction, and here also you consider a small area and the normal is in this direction and the electric field is in this direction. So what happened here? The electric field intensity and the normal drawn to that surface are both perpendicular. Therefore the flux here is 0, and this is also small ds and electric field E. In this case, flux is 0. So in the case of 1, in the first case, the upper surface, the flux is 0, since flux equal to E dot ds, that is equal to E ds cos theta. But here theta is 90 degrees. This angle is 90 degrees. And this angle is also 90 degrees. Therefore, the flux in this direction, is 0. In the upward direction, normal to the top surface and normal to the bottom surface. Due to this charge, the electric field in this direction is, flux in this direction is 0. So you can ignore the flux in the upward direction and the bottom direction, or to the surface, top surface and bottom surface, there is no flux. So the flux is only in this direction. So this is E, and the normal drawn to the surface, both are in the same direction. So the electric flux exists only around the spherical shape or the cylindrical surface, not at the bottom and top. So you will just get the electric flux in this area. Therefore, in the case of the third surface, this is for 1 and 2, flux is 0. For surface 3, I write here, for surface 3, flux is equal to E dot ds. Flux equal to E dot ds. And as per definition, for the total surface of 3, this is only for one particular area, small area. But you want to find the total area. Say this is the cylindrical shape, I already told you now, this shape. And if this consists a small area, I consider here. But there are how many such areas are there? If you have to integrate closed integral, ds will give you the surface area. If I just remove this, you will be getting a rectangle like this, and this will give the circumference of the circular or cylindrical shape 2 pi r, and this will give you the length. Then what is the area of this rectangular shape or outer part of the cylinder 2 pi r into L. So now if you cut this, you will be getting a rectangle like this. You will getting a rectangle like this. Then with what length? 2 pi r length, and breadth is L. So in order to find the total flux, we have to find the total flux due to this total area of the third part is equal to closed integral E dot ds. That is equal to closed integral, I will just remove this, E closed integral ds. But what is ds I told you now? Here it is 2 pi r. So area of this is 2 pi r into L. 2 pi r L. So I write here this equal to E into 2 pi r L. So this is the flux. But we know L is equal to, from this formula, Q is equal to L lambda, or this will also, from this formula, this will also can be written as L is equal to Q by lambda. So this can be written as E into, I will write something here. So we know lambda is equal to Q by L, therefore L is equal to Q by lambda. Now you substitute this value in this equation, phi become, for third surface, become E into 2 pi r into L. You can write down Q by lambda. This is the left hand side part. Now what is the right hand side part according to Gauss law? According to Gauss law, this flux is equal to, phi is equal to closed integral E bar dot ds bar is equal to Q by epsilon naught. Now you just compare these two equations. We will get E into 2 pi r into Q by lambda is equal to Q by epsilon naught. Then what happened here? These two can be cancelled. Now you want to find the value of electric field intensity. E is equal to lambda by 2 pi r into epsilon naught. This is the electric field intensity due to the long straight wire carrying the uniform linear density lambda. Now let us go to observe the next important concept is the electric field intensity due to the thin sheet having uniform density, charge density. Now let us see in this concept expression for electric intensity due to an infinite plane sheet of charge. So we can consider this is the infinite plane sheet of charge which consists a uniform charge density. See the uniform charge density of this area. Charge density. Uniform charge density. Density of the surface of the surface. Small surface if you consider, we can write down this as sigma is equal to small charge in small area, or we can also define this as charge by area. So this implies surface area is equal to Q by sigma. And now let us consider on this sheet a small Gaussian cylinder, horizontal Gaussian cylinder. This is horizontal Gaussian cylinder, Gaussian surface. Let us imagine horizontal Gaussian cylinder surface. Cylindrical surface. Now what happened? This is the, so with the total length of the cylinder is 2r. So this length is r and this length is r. Now the electric field in this direction. Now let us observe the 4 different parts of the surface around which we can estimate the lines of force. You just imagine that this is one surface. I write here this is ds1, and I write here there is another surface ds2. I imagine some surface here in the downward direction. So I write here ds3. I just imagine some surface here. This is ds4. And I imagine some another surface here in the upward direction or in the downward direction. In all the cases, what happened? See, the electric field is in this direction. The electric field is in the direction of normal to the surface of ds1 and normal to the surface of ds2. So the lines of force in the normal to this direction, upward and downward, the lines of force is 0 because these two are perpendicular. E and S are mutually perpendicular. So in case of this ds4 and ds3, ds4, the flux is 0, and in case of this is E and this is ds3. Since this is 90 degrees, here also flux is 0. Even on the other side, you write this as ds surface 5, this is surface 6. So in all the cases, when this is the electric field direction. So when the electric field direction and the normal drawn to that surface are in the same direction, you will get the electric flux and lines of force. And whereas the normal to the direction of the electric field, the surface normal drawn to the surface perpendicular to the electric field, then the lines of force flux become 0. So in which case we have flux only in this direction, along this length of the cylinder, horizontal direction, that is normal to the ds1, surface ds1 and surface ds2. The normal to ds1 and ds2 are in the direction of electric field. Therefore, we have flux only in one direction, that is along ds1 and along ds2. So the electric flux according to the Gauss law, phi is equal to closed integral E bar dot ds is equal to q by epsilon naught. But ds is, there are two surfaces. There are two surfaces under our consideration. One is ds1 and another one is ds2. So I write here that flux, this is equal to closed integral, I write here E is a constant value, closed integral, ds means how many surfaces there? Two surfaces. I write here simply ds is equal to q by epsilon naught. But there are two surfaces. So I write here the total surface area is S plus S is equal to q by epsilon naught. I simply write 2Es is equal to q by epsilon naught. But what is, you want to find E. You want to find E. So E is equal to q by 2S into epsilon naught. This is epsilon naught. Now you can write down this as, instead of S, you can write q by sigma. So q by 2 into, you write q by sigma into epsilon naught. So finally E electric field intensity due to this sheet, E is equal to, see you can cancel this q and sigma goes up, so sigma by 2 epsilon naught. So this is the electric field intensity due to a long sheet carrying uniform charge density. So this is regarding the two types of electric field intensities in case of long straight wire carrying uniform charge density and a long sheet carrying uniform charge density. So in this case, the electric field intensity is equal to sigma by 2 epsilon naught. Sigma by 2 epsilon naught. This is the final formula. Now this can be used in capacitors. Say, expression for electric intensity due to a charged conducting spherical shell at different cases. One is at point outside the shell, at point on the surface of the shell, and a point inside the shell. Now let us see, we consider a spherical shell. Let us consider a spherical shell of, this is the shell. Consider the spherical shell. Of radius R. You consider the somewhere charge here, and the radius of this is capital R, and you consider any point outside the spherical shell which is at a distance of R, You consider any point P. Now what is the electric field intensity at this point? E is equal to, according to definition, E dot ds is equal to Q by epsilon naught. So ds is the surface area of the sphere. So E into closed integral ds is 4 pi r square, but here 4 pi r square is equal to Q by epsilon naught. See, the surface area here it is smaller because we are considering for this one, this surface, on this surface. So I write here small r square. So in this case E is equal to Q by 4 pi epsilon naught small r square. But as you know, the surface charge density is equal to charge by area 4 pi r square, capital R square. This implies Q is equal to 4 pi r square into sigma. So in the place of Q, if you substitute E is equal to, the place of Q you substitute 4 pi capital R square into sigma by 4 pi epsilon naught into R square. So the 4 pi cancelled. So you will be getting this equal to sigma by epsilon naught into R square by R square. So this is the value of electric field intensity outside the spherical shell at a distance of r. So I write here E is equal to, in this case, E outside is equal to, I write here the formula sigma by epsilon naught into capital R square by small r square. This r is the radius of the sphere, r is the distance, at a distance from the center of the sphere, spherical shell. Now a point on the surface of the shell. See, if you consider a point on the exactly surface of the shell. So on surface of the shell what happened? Small r become capital R. Therefore E on the surface is equal to simply sigma by epsilon naught. Sigma by epsilon naught. So a point inside the shell. A point inside the shell, E is equal to 0 inside. Because charge do not lie inside the surface. If you imagine somewhere here, and here it is 0. Inside the surface there is no charge. So E is 0 inside the surface. These are all the three different situations for the spherical shell, but this will not come for public examination. This come under 30% deleted syllabus, particularly the spherical shell, Gauss law application for spherical shell, but very important for the solving problems IIT and NEET. Now one more concept we have to observe here, That is, if you see the how the variation of electric field intensity. Suppose you take electric field intensity on x-axis, and this is the distance. I will write down distance on x-axis. Then what happens if you imagine that this is the spherical shell, and exactly at center, at this point, from this point to the edge surface here up to the surface, the charge is E is 0, so there is no intensity at this particular place. There is no intensity here. E inside is 0. That means this radius less than R is less value than that of R is very less. And if it is, this is less than R. And at this point, this is less than R. And this point, R is equal to R. And beyond this point, if you go, increase the distance, you will be getting E outside is proportional to 1 by R square. So you will get the intensity exponentially decreasing. So this is how you can observe and this is R greater than R is greater than R. So this is particular area is less than R. This is at R is equal to R, and this particular part is greater than R. So in all these cases, you can observe the fields variation of electric field intensity. So in this area, the electric field is 0. Here it is exactly 1 by this, here it is exactly 1 by 4 pi epsilon naught q by R square or small r square, and here it is inversely proportional, so it gradually decreasing its value. Now this is how we can observe the variation of the electric field intensity inside the spherical shell, outside the spherical shell, and exactly on the surface of the spherical shell. Now let us see what is the importance and what are the uses of the Gauss law. See, the first one, it is useful in calculating the electric field. You can find the intensity of electric field using Gauss law for different bodies. And the second one is Gauss law is true for any closed surface no matter what its shape or size. We can apply the Gauss law to any closed surface irrespective of its shape and size. That is the main advantage. And next one, symmetric considerations in many problems make the application of Gauss law much easier. Using this, we can solve the problems very easier because of the symmetric conditions. We can apply this Gauss law in different situations while solving the problems. Now, we can also derive the Coulomb's law. or you can check whether the Coulomb's law is correct or not using Gauss law. So Coulomb's law can be derived from Gauss law. We can derive the Maxwell's equations of electromagnetism. In the electromagnetism, there are certain Maxwell's equations, and in the electromagnetic waves, we can observe this particular part. But Gauss law can be used to derive the Maxwell's electromagnetic equations. And the next one is, it tells us the number of field lines passing through a given area of closed surface, that is Gaussian body. So we can estimate the number of lines of force which are passing through the Gaussian body. These are all the important applications or the uses of the Gauss law. This is very, very important part. This will be coming for 4 marks question in intermediate. So these are all the different applications. You can write any 3 in the examination. Now let us solve some problems. Say for example, in this case, an electric dipole with dipole moment 4 into 10 power of minus 9 Coulomb meter, not centimeter, it is Coulomb meter, is aligned at 30 degrees with the direction of a uniform electric field of magnitude 5 into 10 power of 4 Newton per Coulomb. Calculate the magnitude of the torque on the dipole. So when you are going to solve any problem, first we have to observe what is the data given. So the given data is like electric dipole with dipole moment P. P is given 4 into 10 power of minus 9 Coulomb meters. Coulomb meter. And it is aligned with an angle 30 degrees with the direction of the uniform electric field of magnitude. Uniform electric field magnitude is also given 5 into 10 power of 4 newtons per coulomb. Then what you have to find? You have to find the torque. What is the torque on the tau? You have to find the torque. See, actually, there is an electric field, uniform electric field, in which a dipole is aligned in this way. A dipole is aligned in this way. So this dipole is plus and this is minus. And this dipole is making angle theta with uniform electric field. This is the electric field lines. And this is a dipole. And in this case, what is the torque? See, here the force acting in this direction and force acting in this direction, equal and opposite directions, forces are. So it undergo torque. There is a rotational effect. It undergo torque. So the torque formula for torque or couple, formula for torque or couple is equal to P cross E, that is equal to P sin theta into n cap. So you have been asked only magnitude, so we need not bother about the torque. So P is given 4 into, so torque is equal to only magnitude, you are going to find only its magnitude. P is given 4 into 10 power of minus 9. All units are in SI system. And E is given 5 into 10 power of 4 Newton per Coulomb into sin 30 degrees, that is half. So we can write down this finally as is equal to 4 into 10 power 4 5s are 20 into 10 power of minus 5 into 1 by 2, that is equal to 10 into 10 power of minus 5. Torque is nothing but Newton meter. The unit of torque is Newton meter. So finally the torque, magnitude of torque is equal to 10 power of minus 4 Newton meter. This is the answer. 10 power of minus 4 Newton meter. Now let us observe the another type of problem. Now let us see the questions, most important questions for IP public examinations. The first one is state and explain Coulomb's inverse square law in electricity. The next one is define intensity of electric field at a point. Derive an expression for the intensity due to a point charge. The second question. Third one. Derive the equation for the couple acting on a electric dipole in a uniform electric field. And the fourth one. Derive an expression for intensity of electric field at a point on the axial line of an electric dipole. And the fifth one. Derive an expression for intensity of electric field at a point on equatorial plane of an electric dipole. And the last and final. State Gauss law in electrostatics and explain its importance. If you follow all the schedules or the modules of the electric charges and fields, you could be able to solve or answer all of these questions one by one. So these are the most important part of the electric charges and fields. This will be very much useful for intermediate public examination. And one more thing is not included, deleted. See, using Gauss law to determine the electric field intensity of a spherical shell, outside the spherical shell, inside the spherical shell, and on the spherical shell. Of course, that is deleted part of the syllabus during the time of this COVID-19. You observe all the questions. So for this, you have to write down the Coulomb's law and you have to derive the expression for Coulomb's law. If you have to derive E is equal to, for this you have to derive F equal to K into Q1 Q2 by R square, where K is equal to 1 by 4 pi epsilon naught. In SI system, its value is 9 into 10 power of 9. Its value is Newton meter square by Coulomb square. And for intensity of electric field at a point, E is equal to 1 by 4 pi epsilon naught q by r square, since E is equal to F by Q naught. And for derive the equation for the couple acting, so for this question we have to write down the couple is equal to P cross E, that is equal to PE sin theta. This is for the third question. And for the fourth one, derive an expression for the intensity of electric field at a point on the axial line of electric dipole. So for this we have to write down, we have to derive the expression for the short dipole. E is equal to 1 by 4 pi epsilon naught 2p by r cube. And for the fifth one, this is on axial line. For the fifth one on equatorial line is equal to 1 by 4 pi epsilon naught p by r cube. This is regarding fourth one, and this is fifth one. For the sixth one, what you have to do is, you know the Gauss law, phi is equal to closed integral E dot ds is equal to q by epsilon naught. So these are all the formulae that you are supposed to derive.
Good morning to everyone. My name is Sukanya. I am Maths PGT, KGBV Vallikurva, Prakasam district. Now today we will discuss the chapter Parabola. In this chapter, weightage is 7 plus 2, total 9 marks for given public examination. First, introduction to the parabola. We know that conic section. Conic section. Now we have discussed the circle, next cone circle, about the parabola. Before we discuss the parabola, I need most take the most important topic in which circle, parabola, ellipse, hyperbola and different types of two-dimensional stretches are given. Now we going to the conic section. Here conic section, let's see how the different types of two-dimensional stretchers like circles, parabola, etc. Initially I take the cone. This is the three-dimensional cone. Let's see conic section of different types of stretchers, shapes and various types of cutting of the cone. Suppose I take the cone, cutting the perpendicular to the base, we get the circle. Now cutting the perpendicular to the base, we get the circle. So this cutting the perpendicular, we can shape like this. This is the circle. This is also formed a circle. Similarly, we have another type of the conic section through which I get the parabola. what kind of cutting of the cone and what kind of the cutting angle of the cone, so I get parabola. Now take another code. And cutting the some side of the cone. This and cutting the some side of the cone, we form U shape. You can form the shape is U. This is called parabola. The parabola like the shape is U shape. This form the shape is parabola. Next, when I take the double cone, this is when I take the double cone. In this case, I cutting the sum this side. We get the shapes. We form these shapes. This shape is called hyperbola. This is hyperbola. If I have the cone, if I have the cone, if I have the cone and cutting the other than the 90 degrees, other than I cut the cone other than the 90 degrees, we get the shapes. We get the shape ellipse. In this ellipse shape, like as egg shape. This is the ellipse. I cut the cone about the angle 90 degrees. Next, we go to the conical. Suppose we have this is axis, this is directrix. Let S be the focus, P be the any point, M is the perpendicular distance from point to directrix. Let P the locus of the P, x comma y. The distance between the SP and by the distance between the PM and the concentration that have SP by PM is equal E, a constant. The locus of P of x comma y is a conic. This S means focus. E means eccentricity. S is the fixed point or fixed point. Fixed point. Fixed point is called focus. And fixed straight line is called directrix. The perpendicular distance, perpendicular to the directrix, passing through focus, passing through the fixed point focus is called axis. Axis and directrix are connected to the conic section. That E plays vital role in deciding the shape of the conical. Suppose SB by PM is equal to E. If E is equal to 1, implies conic is parabola. Zero less than E less than 1, and conic is ellipse. E greater than 1, the conic is hyperbola. This is 3 types of the conic section. Next, equation of the parabola. Equation of the parabola. Now, we draw the diagram. This is the axis. This is directrix. Now we draw the parabola. S be the focus, P be the any point of the locus, M is the perpendicular distance to point to 10. We know that SP by PM is equal to E. Let S be the alpha comma beta, P be the x1 comma y1 be any point on the locus, and the directrix line Lx plus My plus N is equal to 0. SP by PM, E is equal to 1. SP by PM is equal to 1. SP is equal to PM. SP means distance between the two S and P. PM means the perpendicular distance. Perpendicular distance point to directrix. Directrix. SP means distance between the point to focus. Distance, we know that the formula, distance between the 2 points, the formula is y2 minus y1 whole square plus x2 minus x1 whole square. This is the formula to find the distance between the 2 points. Where similarly, S is the alpha comma beta, P is the x1 comma y1. Square root of x1 minus alpha whole square plus y1 minus beta whole square is equal to PM means perpendicular distance from point to directrix. The formula is Lx plus My plus N by square root of L square plus N square. Squaring on both sides. Square root of x1 minus alpha whole square plus y1 minus beta whole square is equal Lx plus My plus N by root of L square plus M square whole square. Square की root की cancel. Now we can write x1 minus alpha whole square plus y1 minus beta whole square is equal Square is separate, numerator to denominator. Lx plus my plus n whole square by square ki root ki cancel. L square plus m square. Now cross multiplication. x1 minus alpha whole square plus y minus beta whole square into L square plus m square is equal Lx plus my plus n whole square. This is the formula for equation of the parabola. Next, standard form of the parabola. Standard form. Y square is equal 4ax. First we draw the diagram. This is x-axis. This is the y-axis. Now we draw the parabola. S be the focus, P be the any point on the locus, M means the perpendicular distance from point to directrix. Is the any point N. This is the directrix line. L is equal to 0. M, Z, midpoint E. The focus point A, 0. P is x1, y1. Now we go to the proof. Let S be the focus. L is equal to 0 be the directrix of the parabola. Let P of x1, y1 be any point on the parabola. Let M, Z are the projections of P. L is equal to 0 respectively. Let A be the midpoint of SZ. A be the midpoint of SZ. SZ means SA plus AZ. SA is equal AZ. This is total. We form the SZ. A is the point on the parabola. Let SA is equal A. Like midpoint A is 0, 0. Focus S is equal A, 0. Now PM. The PM is parallel to NZ. PM is equal NZ. This nz means az plus sc. This nz means na plus az. Sp means the distance between the point to focus. That is x1 minus alpha whole square, x1 minus a whole square plus y1 minus 0 whole square. We know that Sp is equal to Pm. Sp means square root of x1 minus a whole square plus y1 minus 0 whole square is equal. Now Pm is equal nz. This nz means
is equal to
this nz means na plus az. This nz means na plus az. This is na means x1, az means a. Next, Sp is equal distance between the focus to point. Distance between focus point a comma 0, point x1 comma y1. Square root of x1 minus a whole square plus y1 minus 0 whole square. We know that Sp is equal to Pm. Sp means square root of x1 minus a whole square plus y1 minus 0 whole square is equal to Pm means x1 plus a. Square root of x1 minus a whole square plus y1 minus 0 whole square is equal to x1 plus a whole square. Square ki root ki cancel, then we write x1 minus a whole square plus y1 whole square is equal to x1 plus a whole square. This is the formula for a minus b whole square. This is the formula for a plus b whole square. We know that formula a plus b whole square is equal a square plus b square plus 2ab. A minus b whole square is equal a square plus b square minus 2ab. This is also exponent. x1 square plus a square minus 2a x1 plus y1 square is equal. This is also expand. x1 square plus a square plus 2a x1. Now we cancel the same terms. x1 square, x1 square. Next, a square, a square. Now we get right minus 2a x1 plus y1 square is equal 2a x1. Next, y1 square is equal minus 2a x1. We can write right side plus 2a x1. y1 square is equal to 2 plus 2, 4. 4a x1. The locus of P x1 y1 is y square is equal 4ax. This is the standard form of the parabola. Next, various form of parabola. Y square is equal to 4ax. A greater than 0. Now we draw the diagram. This is x-axis, this is y-axis. Now we draw the parabola. In y square is equal to 4ax, a greater than 0. It is the positive side. We draw the parabola. S be the focus. Focus means a comma 0. This is the directrix line. X plus a is equal to 0. Focus S is a comma 0. Equation of the directrix. Equation of directrix is equal to x plus a is equal to 0. And axis of the parabola. Axis of the parabola. In this x-axis, y coordinates 0. So y is equal to 0. Vertex. This focus is passes through origin. Vertex is 0, 0. Next. Y square is equal to minus 4ax. A greater than 0. In this case, we draw the diagram. This is x-axis. This is y-axis. We draw the parabola. Y square is equal to minus 4ax. We can draw the negative side of the parabola. Minus 4ax. X replaced with minus x. So we can draw the parabola in negative side. This is focus minus a comma 0. This is the directrix line. X minus a is equal to 0. In this case, focus S is equal to minus a comma 0. Equation of the directrix. Equation of the directrix is equal to x minus a is equal to 0. Next, axis of the parabola. Y is equal to 0 because focus is passes through x-axis. Y coordinates is 0. Vertex is also 0, 0. Next, third type. Next type, x square is equal to 4ay. A greater than 0. Now we draw the diagram. X-axis. This is the y-axis. We draw the parabola upside because x square is equal to 4ay. We take the parabola in y-axis. So we draw the parabola upside. This side. Focus is 0, a. And directrix line is this. Y plus a is equal to 0. In this case, focus is S is equal to a, 0, 0, a. Equation of the directrix. Equation of directrix. Y plus a is equal to 0. Next, axis of the parabola. in y-axis, x coordinates is 0. So x is equal 0. Next, it is the same, vertex is origin, 0 comma 0. Next tab, x square is equal minus 4a by a greater than 0. Now we draw the diagram. X-axis, y-axis. In this case, we draw the parabola downside of the axis because x square is equal to minus 4a by. So we draw the negative side. So we must be write the parabola. This one. Focus S is 0 comma minus c. And equation of the directrix is this one. Y minus c is equal 0. In this case, focus S is equal 0 comma minus c. Equation of the directrix y minus a is equal 0. Equation of the axis of the parabola this is y coordinate, y axis, x coordinates is 0. Next, vertex is 0 comma 0. Next, y minus k whole square is equal 4a into x minus h. In this case, we draw the diagram. This is x-axis, this is y-axis. We draw the parabola. This focus is S. In this type, y minus k is equal 0. Equation of the directrix y minus k is equal 0. This one, x minus h plus a is equal 0. In this case, focus is S is equal h plus a comma 0. Equation of the directrix. X minus h plus a is equal 0. Axis of the parabola. Axis of the parabola is y minus k is equal 0. And vertex is h comma k. Here h greater than 0, k greater than 0. Next case, y minus k whole square is equal to minus 4a x minus h. In this case, we draw the diagram. X-axis, y-axis. In this case, we draw the parabola negative side. This is the positive side, this is negative side. We take the parabola in negative side. So, we can draw this one. This is the directrix line. Axis of the parabola y minus k is equal to 0. Equation of the directrix x minus h minus a is equal to 0. In this case, the focus is S is h minus a comma k. Equation of the directrix is x minus h minus a is equal to 0. Next, axis of the parabola. Y minus k is equal to 0. Vertex is h comma k. Here h less than a, k greater than 0. Next case, x minus h whole square is equal to 4a into y minus k. In this case, we draw the diagram. This is x-axis, this is y-axis. We draw the parabola this type. Focus is this is the directrix line. And axis of the parabola x minus h is equal to 0. Equation of the directrix y minus k plus a is equal to 0. In this case, focus is h comma a plus k. Equation of the directrix y minus k plus a is equal to 0. Next, axis of the parabola h minus x is equal to 0. And also vertex is h comma k. Here h greater than 0, k greater than 0. Next case, x minus h whole square is equal minus 4a into y minus k. In this case, we draw the diagram. X-axis, this is the y-axis. We draw the parabola. Focus S and equation of the directrix. Equation of the directrix y minus k minus a is equal to 0. And equation of the axis is x minus h is equal to 0. In this case, the focus S is equal to h comma k minus a. Equation of the directrix is equal to y minus k minus a is equal to 0. And axis of the parabola x minus h is equal to 0. And vertex is h comma k. In this case, h greater than 0, k greater than a. This is all the types.